paleocurrents as tools. Now, what are paleocurrents? This is fascinating stuff. A paleocurrent. Paleocurrents are flow directions derived from features of sedimentary rock that reveal the direction or sense of the current of wind or water that deposited the sediment. All sedimentary rocks contain paleocurrent indicators, some which can be read and interpreted. So now if you go and look at the various layers of rock, some of it is exposed because the top layer is cracked off, and you can see, well, in which way did the water flow over this layer of rock. If science says that each one of those layers was once the surface of the earth, let's have a look at them individual all over the world and see in which way the water flowed supposedly during that time. That would be interesting. So what do we know? The results are there of some million measurements in the database. That's pretty much. Now, if you have a continent has basins, and a continent has areas where water flows in a particular direction towards the ocean. So in the United States of America, for example, there are these basins, and the water will flow from all the directions into the basins. Plus, there will be flow directions out towards the ocean. And that is a typical modern scenario. So, if we have a look at the general appearance today, here on the one side, the water will be flowing, generally speaking, towards the coast. There will be basins in the center, basins where water flows from all directions into the basins, and then you'll have flow directions to the oceans, etc., on the other sides. And then you can have, between all of them, you can have rivers flowing towards the oceans. That's a typical modern world. And that's what any world should have looked like if the conditions were roughly similar in the past. Is that correct? Okay. Do we have that? The answer is no. If we go to the Paleozoic, that's at the bottom, the lowest layer, we find this very interesting phenomenon. Instead of having basins, there are none. From all the measurements that have been made, it appears that the water flowed in this direction. In other words, generally speaking, from the one side here, from the east coast, generally to the southwest, right across the continent. If you go to the next layer, the Mesozoic, what do you find? Total reverse. Suddenly, things are going in the opposite direction. If you look at the somewhat higher layers, the tertiary, we seem to find somewhat different patterns, some going this way, some going that way, some going this way. So there seems to be some form of restoration taking place. A little bit higher, we seem to have some going this way, some going that way, others going that way, and still higher, we seem to have some reversals. So what do we find? Summary. Precambrian. North America paleocurrents are variable across the craton, show no distinctive continent-wide pattern. So right down at the bottom, it's the same as what you would expect today. So maybe the Precambrian was once the surface of the earth. That's consistent. The Paleozoic, suddenly you show patterns that are continent-wide and typically flow towards the west and southwest across the continent. That's impossible. You cannot have water flowing from one side of the United States all the way across to the other side, and Canada and everything else. And then in the next time, all the way in the opposite direction. In the Mesozoic, exactly the opposite. It goes from the west to the east, and then in the Cenozoic, there seems to be some continued pattern of the Cretaceous, Paleozoic, but become variable, so they start becoming normal again. So what happened here in the Paleozoic and Mesozoic is inexplicable. These trends are not expected in the standard model of geology. The trends reveal processes that were much larger than anything that you see today, and they are consistent with the global flood. Let's go to South America. What would you expect in the Precambrian and in the Paleozoic? Precambrian, you have basins, you have all these strange things, not many measurements around. If you go a little bit higher, suddenly, boom, the water flowed right across the continent. Can it do that today? No. What happens here today? What's there? A huge mountain range. There is no way that the water can flow from one side right across to the other side, exactly as in North America. Wow! Water flowed right across North and South America in one direction in the Paleozoic. And in the Mesozoic, exactly in the opposite direction. Is this possible? No. Only with the universal flood would this be possible. If you come up higher, then you start getting variability again, as you would expect. So summary, if you read it through, exactly the same pattern as you have in North America. This is unbelievable. If you put all the continents together, you have a universal pattern. So the sediments seem to have come here from the center, and the flow directions were universal. So this is an amazing story